In this video, we're going to learn to check if a given number is Armstrong or not using C# in Visual Studio 2017 with for loop statements. First of all, let's see what is an Armstrong number. For any number having n digits, it's said to be an Armstrong number if the sum of its digits powered to n is equal to the number itself. For example, if we have 3-digit number 153, then n equals to 3 because it's a 3-digit number, then the sum of its individual digits powered to 3 would be equal to the number of itself, 153, if it's an Armstrong number. Let's see here, like our first digit 1 cube plus second digit 5 cube plus third digit 3 cube equals to 153, so it's an Armstrong number. Let's look at another example, which is 4-digit number, which is 1634. Here n equals to 4, so based on the definition here, we know if we power each of its digits to 4 and sum them up, we're going to get 1634 if it's an Armstrong number. So here 1 to the power 4 plus 6 to the power 4 plus 3 to the power 4 plus 4 to the power 4 equals to 1634, so it's an Armstrong number. So now we know what is an Armstrong number. Let's look at how to program it in C#. So step 1, we need to get a user input. Console.Write, it asks users to enter a number and then stores it into n by converting into an integer. Now we got n equals to 153. Say for this example, user inputs 153 as a number. Then step 2, we're going to check the number of digits in the user input number. How we can do that? So here's a simple coding here. I'm going to walk you through this loop. We're using for loop. We are initiating the number of counts equals to 0 first, and then our loop starts. For the start of the loop, our any variable c would be equals to n, which is 153, what user input at the first, and then it goes into the second step, checks if c is equals to 0 or not. No, it's 153, so it goes into another steps into the loop, count plus plus, it will add 1 to the count, so 0 plus 1 would be 1, and in the next step, it will one step further, the c value of the c would be 153 by 10, that would be 15. Now 153 by 10 is actually 15.3, but because we put the int in front of c, the type of the variable c is integer, so it only takes the 15 and it takes out the values after decimal. So now it goes into second step. Now that we have count equals to 1, c would be equals to 15. I don't know why I put n here, but it's actually c equals to 15. That comes from here, and then goes into checking if c is equals to 0. No, and then count, it will add 1 to the count. 1 plus 1 will be 2, and it will change the c to c by 10 again, which is 15 by 10, and again it's 1.5, but it only takes the number that's outside of the decimal, that's 1. Now into the third loop, our count is equals to 2, and our c would be 1 from here. Let me just put this out here. So this is not n, and this is not n. Okay. Now c equals to 1, it goes into second step to check if c is equals to 0 or not. No. And then it goes to the loop, adds 1 to the count. We already have count equals to 2. Now 2 plus 1 is 3. Now next step is c equals to c by 10. 1 by 10 would be 0 because 1 by 10 is 0.1, and it removes the number after decimal, so it's only 0. Now in the fourth loop, we have count equals to 3, but c is already equals to 0. So when it checks if c is equals to 0 or not, it's yes, then our loop ends. Then the count would be equals to 3. So that means the number that we input, 153, has 3 digits. Now step 3, we need to calculate the sum of the cubes of the digits. How do we do that? We have a simple code here. We first initialize the sum as 0, and then we have a for loop where our loop starts as I equals to n, which is equals to 153 as a user input. Then computer checks if I is equals to 0 or not. No. Then it goes further into the loop, and then it calculates the remainder of the number that was input. So we have I equals to 153. 153 by 10, we get the remainder 3. That is, we get the ones digit of the 3-digit number in remainder. Then further it calculates sum equals to Math.Pow, which is a simple syntax that we find in C# to find the power of any variable with respect to another variable y. So here what it does is it calculates the power of cube of remainder, and I've used typecasting here because Math.Pow calculates the number in double type, and then I changed it into integer because every other numbers we have is in integer. Then it adds it into our initial sum value, which is 0. So our sum would be equals to 3 cube plus 0 now. Now next, what it does, I equals to I by 10. I equals to I by 10 would be 153 by 10, which is equal to 15, as again it removes the number after decimal. Now second loop. In second loop, sum would be equals to 3 cube and I would be equals to 15. Now it checks if I is equals to 0. No. It goes to the loop, calculates the remainder. We have I equals to 15. 15 by 10, we have a remainder of 5, which is the second or 10th place of our 3-digit number. Now again it calculates the sum equals to 5 remainders cube, which is 5 cube, plus we already have sum of 3 cube from the loop 1. Now it goes to another step. It makes I equals to 15 by 10, and which is 1 because 1.5, it removes the number after decimal, it's just 1. In third loop, we have now sum equals to 5 cube plus 3 cube, and I equals to 1 from here. Now again it checks if I is equals to 0 or not. Nope. We go to the loop, remainder equals to I by 10. So 1 by 10 basically has a remainder of 1, and then it calculates 1 cube, puts it into the sum, and we have 1 cube plus 5 cubes plus 3 cube. And next step, it calculates I equals to 1 by 10, 1 by 10, and value would be 0 because 0.1, it removes the decimal number after decimal, so I equals to 0. Last loop, we have sum equals to 1 cube plus 5 cubes plus 3 cube, I equals to 0. It checks if I equals to 0 or not. Yes. Then our loop ends. So when our loop ends, we have sum equals to 1 cube plus 5 cube plus 3 cube, which is 153. Now we got the sum of the cubes of the digits. Next step, we're going to check if the sum is equals to input or not. To do this, we use the simple if-else decision-making statement, where if sum is equal to n, then we print out it is an Armstrong number. If it is not, then we just print it out it is not an Armstrong number. So what this code does is, we've got sum equals to 153. It checks if it is equal to n equals to 153 or not. If yes, it is in our case, so it is an Armstrong number. Okay, now that we know that how our program is going to function and what is an Armstrong number is, let's go back to C# and implement those code into it and actually check our programs. So I've got here a namespace of CSharpExercise. We're inside the class program, and then we have like static void main. Inside there, our first step would be user input. So I'm just gonna Console.Write, let's say enter a number, and will be int n, convert it into integer because any input that we get from user while using this would be in string format. Now read line. So we've got n here. Now what was the second step that we did? We had number digit count. So in this step, what we did was first initiated the count as 0, and then used a for loop for, let's say, any variable c equals to n, which is the number that was input by user. Checks if c is equals to 0 or not in the second step, and then advance it to C by 10 for the next loop. Within that loop, we had count plus plus. Once the count is done, we can just print it for the readability of the program. Let's say number of digits in a number equals to count. It doesn't make sense. Number of digits in a number. Okay, digits in a number. Count. Okay. Now let's go to step number 3, where we had done calculate the sum of the digits for n equals to 3, which we did was cubed here. Let's say if count equals to 3, then we can have a separate program here, and later on if we want to calculate the Armstrong number of 4-digit number, then we can just repeat the same program, but you put it inside the decision making statement of if count equals to 4. We can do that later on, but let's just work on if count equals to 3 here. Now we initiated sum equals to 0. Now using for loop, let's say our variable I would be equals to the user input n, checks if I is equals to 0 or not, and then for the second loop it just changes the value of I by 10. Inside the loop, once it's inside the loop, it calculates the remainder. That would be I by 10, and sum would be typecast int here, Math.Pow. Let's say we're calculating remainder, and that'll be cubed, or you can also put in count if that's easier for you. That's pretty much it, plus the sum, because our initial value is 0. Now let's print. We can't. Let's print the cube. Let's do this. So if we do this, remainder, that would be remainder cube plus, I think I made a mistake. It should be inside the loop here. So it's gonna calculate remainder, calculate sum, and then it's just gonna print out the remainder, cube of the remainder. That's the indication. Then let's just give a space here, 1 line space, and print out the sum here. Sum of the digits cubed equals to, that'll be our sum. Let's just put it 0, do it like this way, sum. I think that's pretty much it. Now our fourth step was to check if sum is equal to n or not. We can easily do that. If sum is equal to n, then print it is an Armstrong number, else else it is not an Armstrong number. That should be pretty much it. I think we're all into like step 1, 2, count, 3, 4. Okay, let's just run this number and see if we got it right or not. Okay, enter a number, let's say 153. This in a number equals to 3 cube plus 5 cube plus 1 cube. Sum of this cube equals to 153, so it is an Armstrong number. Great. Just to make the output readable, I'm just gonna put write line here and here, so that it gets printed out in the same line. 153. Okay. 153. So let's check in for another number, say 256, a random 3-digit number. Sum of the digit equals 133. It is not an Armstrong number. Correct. So now what do we do if we have like 4-digit numbers? So that's why we calculated count, right? So if we have this, copy this here. Now we're checking for 4-digit numbers. Then if count equals to 4, right? That's just 4. You calculate remainder and 4 count here. Everything is as simple as that. Now if you want to do it for let's say 5-digit number, you can go here, copy here, change this to count equals to 5. For now I'll just stick into 4. Let's just check. We have 1634, 4-digit number. Then digits in a number equals to 4. 4 to the power 4 plus 3 to the power 4 plus 6 to the power 4 plus 1 to the power 4. The sum of the digits cube equals to 1634, so it is an Armstrong number. Let's just check with another 4-digit number, 2054, let's say. Sum of digits cubed equals to, sorry, I need to change this language for the count equals to 4. It is not an Armstrong number, but the gist of the programming, I think it's good here. And I'm just gonna change this to hard 4. Okay. 2054. 4 equals, no, it's not an Armstrong number. That's it for the video to check if the input number is Armstrong or not. If you like the video, please like and subscribe, and if you have any comments, please write in at the comment section below.